Okay, this week you're going to be learning how to calculate the net force that is acting upon an object. In this particular case, this would be an example of perhaps a person that has jumped out of an airplane with a parachute on that has been employed. So the parachute's out. They are affected by gravity as they fall towards the earth. And then they also have air resistance acting against gravity in the opposite direction. That's what parachutes are for, to increase the air resistance enough, that opposing force, that they land on the ground at a speed they can survive. So in this case, the way you calculate the net force is you look at the top force, the up force, and the down force. And my difference between those two numbers, is 2 newtons, and I would say that is in a downward fashion. So that's my net force. Now in this situation, I have 4 different forces. So the way to do that is compare top and bottom. I've got 10 newtons of normal force, 10 newtons of gravity. Those cancel each other out. You don't need to cross these out. I'm going to do that just for illustration point. I then look at my 2 forces from left to right. I have 3 newtons to the left in the form of air resistance, and I have 12 newtons to the right as applied force because somebody is actually pushing something across the ground. So that means that my net force would be 9 newtons to the right, and then that's how I would write it down. So when you're calculating net force, you look at top and bottom, find the difference there, and left and right, and find the difference there. Now, in 9th grade, there might be differences all around. In 8th grade, it'll only be a difference between either left and right forces or a difference between top and bottom. I'm not going to make it complicated on you. For example, this particular case, we would compare that top and bottom. So that means our net force equals 2 newtons up. I want to make a special point here about applied forces. For example, if I throw a baseball straight up in the air, I'm applying a force to that baseball. But the only time I draw that applied force in is when my hand is literally still touching the baseball. Once I let go of it, and that ball is moving up in the air, even though it's still moving up, there's no applied force. I've already applied it once, it's done. But it's moving up, motion's up, that means air resistance is down, and so is gravity. It is possible to have 2 forces going in, 2 different forces acting in the same direction, just so you know.